Hey guys, we actually finally finished the trigonometry unit. Woohoo! Alright, now we're going to be starting the sequences and series unit. This is day one. Today we're talking about a recursive sequence. So first of all, what is a sequence? Well, a sequence is just a list of numbers, or patterns technically. It doesn't have to be numbers. It could be shapes that grow or change that follow some sort of a rule. So like a very simple rule would be 1, 3, 5, or a pattern at least. So this would be a sequence. This pattern is plus 2. Okay, so that's that pattern. We could also have different patterns, like I could write 2, 9, then something like, so this could be plus 7, but it doesn't have to be plus 7. The rule I'm actually trying to use here is times 5 minus 1, so 2 times 5 is actually 10. Let me rewrite that. So I was writing 2, then 9, and then I took a moment to figure out what I was multiplying. It would be 17. So this rule is actually times 2 minus 1. So this is a rule that has a sequence that has two rules in its pattern. But in order to guess the next number of the sequence, we need to figure out what the rule is. But in order to do that, we need to know at least a few numbers in the sequence to try and interpret what the rule is. So let's take a look at this next rule here. Or this is what's called a recursive sequence. So a recursive sequence, there are two types of sequences. The first is called a recursive sequence, which means you generate the list by applying a rule to one number over and over. So in other words, I started with 1, I applied the rule plus 2 to get 3, applied the rule again to get 5. So I just applied the same rule. So in this case, I started at 2, I applied the rule to get 9, and I applied the rule again to get 17. If I wanted the next rule, I just multiply by 2, which is 34, subtract 1, get 33. So we have a rule and a starting number is what makes a recursive sequence. So let's take a look at this next one. 5, 11, 23, 47. So I have to think of a way to get from 5 to 11. So maybe I think it's plus 6. Well, that doesn't work because 11 plus 6 is not 23. So I'd have to change my plan on my rule. All right, so to get from 5 to 11, I can do times 3, which is 15, and then minus 4. But that won't work for getting me to 23 because 11 times 3 is 33. And 33 minus 4 is not going to be 23. So we could just try a few different possibilities. So the rule seems to be times 2 plus 1. That gives me 11. Times 2 is 22. Plus 1 is 23. So that's the rule for this case. And this sequence can be written in two different ways. There are two different ways to write a sequence. They are called sequence notation and function notation. And we're going to write the rules for these in a moment. But first, find the next 3 terms of that sequence. Okay, applying the rule. And while you're doing that, we're going to discuss sequence notation. Or after you've done that, we're going to discuss sequence notation, and then we're going to write the rule for that function. So sequence notation is usually represented by a letter and a subscript. And the subscript is usually n, which is usually a way to distinguish this between a function versus a sequence. It doesn't technically have to be n, it can be any letter, and technically the name of the function, which is the first letter, could be a symbol like theta or something, or some Greek letter alpha, but it doesn't have to be that. But this is generally what sequence notation looks like. It's a name and a subscript. All right? So let's say we were given a sequence named a sub n. That's how this is referred to. A sub 1 would mean the first term in a sequence. A sub 2 would mean the second term. So like if our pattern was 1, 3, 5, this term would be a sub 1, the next term would be a sub 2, this term would be a sub 3. So a sub 20 means the 20th term, but I have to go through all these terms to find the 20th term. So a sub 20 is going to be somewhere down the road. Now, a sub n is the name of the sequence, but it's also an unknown term. So this means any term in the sequence. Any random term is a sub n. But if you were aware you were looking at a sub n, so I'm just going to erase this real quick. So if I had a, Keep clicking on the wrong thing when I'm trying to click on the pen. So if I have an unknown term, and I call this a sub n, the term that comes before it would be a n minus 1. We call this the previous term. And the term before that would be a n minus 2. And the term after that would be the term a n plus 2. What that means is if I'm currently looking at the 20th term, the next term is the... oh, I wrote a 2 here. This should be a 1. What that means is if I'm currently looking at the 20th term, whatever unknown term is, the next term is going to be the 21st, the term before it's going to be the 19th, and the term before that's going to be the 18th, if that makes sense. All right, so a sub 1 just means the term before the term I'm looking for, and a sub 2 means the term before the term I'm looking for, and a sub 1 means the term after the term I'm looking for. And we'll see how to use that in just a moment. So we're going to write the sequence above using sequence notation. So to do that, we need to label some sort of a starting term. So the first term we're going to label is going to be a sub 1. So that's going to be our starting term, which you need some sort of term to base your formula on. So a sub 1 is going to be 5. The first term is 5. We could also just call it a sub 0 instead, which would be fine. The first term doesn't have to be 1. It could be 0, but it's usually 1. Now we're going to write a rule to find any term or an unknown term in this sequence. Well, we said the rule was to multiply by 2 and then, what was it, add 1? Add 1. So we need a rule that says this. But what am I adding to, what am I multiplying by 2? Well, I'm multiplying the term that comes before this term. So whatever term I'm looking for, if I'm looking for the 5th term, I'm going to multiply the 4th term by 2 and add 1. So this rule just says to find any term, take the previous term. It doesn't matter. You don't think of this as subtraction. Think of it as previous. It says take the current term, multiply, to find the current term, or the term you want, take the previous term, multiply it by 2, and then add 1. So this is a recursive sequence. All right, and you can write simple rules like that as well. We can write one for this 1, 2, 3 sequence as well. We'll call it Bn in this case. Bn and B1 is equal to 1. And the rule is to find the B sub n term, I need to find the previous term, which is Bn minus 1, which is a subscript. Everything here is a subscript. And then I have to add 2. So 2 is not a subscript. So this would be the rule for this sequence here. We can write one for this sequence as well. This one we can call Fn, and we'll say that its rule is to look at the term that came before, Fn minus 1. We're going to multiply it by 2 and then subtract 1. And we also need to label that f of 1 is equal to 2, because we need to know the starting value for this sequence. So these are these 3 sequences written in sequence notation. Now, similarly, you can write a sequence in function notation. It means the exact same thing. It's just a different way of looking at it. So these look more like in function form, like f of x is actually a function. You have your sequence name, and you have, it's sort of like the subscript, but it's the term number. So this would be considered the term number. So it doesn't have to be n, it's usually n. It can be x, it can be h of t, it could be anything. But if you're told the problem deals with a sequence, this is going to be considered sequence notation. So just like a sub 1 meant the first term, f of 1 means the first term. F of 2 means the second term. F of 11 would mean the 11th term. So if I wrote that sequence from earlier, 1, 3, 5, this would be the first term, or this would be f sub 1, or f of 1. This would be the second term, which is f of 2. And this would be the third term, which is f of 3. If I wanted to find the 5th term, so if I wanted to find, well, I would skip the 4th term to find the 5th term. I would need to kind of work through the rule for this problem twice. So I would say plus 2, and get 9. So 9 would be f of 5. Now this is why a recursive sequence is not a preferable sequence. There's also something called a explicit sequence, which we'll talk about next class. But the recursive sequence means you need to know the previous term in order to find the next term. So it's not an efficient way to find values, but there are some sequences that can't be represented by a single formula, which is what an explicit sequence is, and we'll talk about that again next class. Now similarly, f of n is the same thing as a of n. It just means an unknown term or the rule, and f of n minus 1 is the previous term, f of n plus 1 would be the next term, and I didn't mention it last time, but f of n plus 2 would mean the term after the next term. So in this case, if I were to erase this sequence and just write, let's just make it h of t, would be some random term in the sequence. The term that comes after it would be h of t plus 1, and the term before that would be h of t minus 1. I don't know what they are, but if we were using that same sequence, let's say this was just some odd number, it would be on that. The one after it would have been 19, the one before it would have been 15, because the rule was to add 2. So once we know one term, we can find the other terms around it. The term that would come after the next term would be h of t plus 2. Hopefully this makes sense. We're going to write the three sequences from above using that notation as well. So this first sequence, instead of calling it a sub 1, I guess we could still call it a. We'll call it in function notation using the rule a of 1 equals 5. And the rule doesn't change, so a of n is going to be equal to 2 times, multiply by 2, and add 1 to the previous term. So the previous term is a of n minus 1. So the difference between these two sequences is that in a sequence notation you write as a subscript, and in function notation you write in a parenthesis. But you just need to realize that this is a solid unit. So not a big difference. So try and do examples 1 through 4 on your own. I'll even help you a little bit. I'll take a look at what the rules say. This rule says your first term is 3, and the rule says to find any term, take the previous term, square it, and subtract 5. So for instance, for the second term, it would be to find the second term, I would use the first term. So the first term was 3. 3 squared is 9, minus 5 is 4. So if I wanted to find the third term, I would have to plug in the second term, which would have been 4, and continue. In the second one, the rule says, starting with 2, to find the next term, multiply by -2 and subtract 5. In the next example, it says start at 1, to find the next term, multiply by 3 and add 2. And the reason this is here is this is the previous term to term 1 is to term 2 is term 1, if that makes sense. For the fourth example, it says the first term is 1, and the rule is to multiply by 3 and add 2. So the term that would come next would be times 3 plus 2, so that's 3 plus 2 is 5. All right. If I wanted to write a sequence, we wrote a few up top. I'll go over some of the more confusing ones down here. So it says find the next 2 terms and write the recursive formula for the sequence. So I'm going to go over the bottom one because it's a trickier one, because you'll notice here it actually gives you the first and second term. You can write a sequence that uses the previous term and the term before the previous term, which is what's happening here. So that means I'm using these first 2 terms, because it gave me those, to find the next one. So this one would be 2 plus 3 minus 1, or add this term. So b1 plus b2 minus 1 gets me to term 4. So let's see, if I tried that here, by that same logic, b2 plus b3 minus 1 should be b4. So 3 plus 4 minus 1 is 6. So that's the rule. So the rule is going to be take the previous term add it to the term before that one, and then subtract 1. So this would be the rule for that sequence. So if I wanted to find the next term in the sequence, which should be the sixth term, so if I want to find B6, I need to take B5, add it to B4, because this is the previous term. This is the term before the previous term, and then subtract 1. So that would mean I would take 6, I would take 9, which was B5, 6, which was B4, add them together, which is 15, and subtract 1, making the next term 14. And then if I were to find the seventh term, so if I wanted to find B7, I would have to take B6, which was 14, and B5, which was 9, add those, get 23, subtract 1, and get 22. All right, so I'll leave the other ones for you guys to try and finish on your own. Let's take a look at some of the Regents problems on the back. Now, there are a lot of Regents problems I didn't include because they deal with knowing what an explicit sequence is, and we haven't done that yet. So I'm just going to look at the trickier parts of this problem. So this one tells us to describe our graph as a sequence. So in this case, this is like, this really means A1, and this would mean A2. And A1 equals 4, and A2 equals 12. So there appears to be a rule like this. So this is just another way of writing it. So writing as a graph is another way of doing this. So this shouldn't be any different from all the other problems. This one should be pretty straightforward. It gives you the first 5 terms, so you have to find the 8th term and write a sequence. So just remember you're going to write either A, N, and A1, or something like that to find this answer. And then you have to find A8th. Taking a look at problem 10, it asks you to find the first 4 terms, which they give you one of them, so you just need to apply the rule correctly. So this says the previous term, multiply by 2, add 1. So you should be able to write it yourself. Now what you won't be able to answer yet is, can you write this sequence using an explicit geometric formula? Now we haven't talked about explicit, geometric, or arithmetic sequences yet, so you won't be answering that part. So just answer the first part of this question. What are the first 4 terms? And the last one, or the second to last one, I forgot I put one on the bottom, is to find a problem scenario that would be modeled using this recursive sequence. Now I could recommend writing the first few terms. Hopefully it'll make sense of what's happening in this example based on that. And this last one here, the pattern's a little bit difficult to find. Like, how do I get from 6 to 9? I can add 3, but that clearly doesn't get me to 13. Oh, 13 and a half even. Usually when you get halves, it involves multiplying by fractions of some sort. A good way to figure out if you're multiplying by a number is to take the two numbers and divide them. So 9 divided by 6 is 3 over 2. That means if I multiplied 6 by 3 over 2, I get 9. So let's say I multiply 9 by 3 over 2. If I get 13 and a half, then this is the pattern. So 9 times 3 is 27. Divided by 2 is 13.5. So the rule here seems to be multiply by 3 halves. So hopefully that helps you when trying to find your formula for this sequence. If you have any questions, let me know. And also complete the Delta Math assignment, which has a lot of practice there.